All right, let's cover the other two. We will come back to number 2. Because number 2 is so prevalent, you'll notice I did not give it a specific name like this. And the reason why is because we actually split it up into a whole bunch of different situations. Yes?
What rank is that on?
Oh, good question. This is actually second. Second strongest. That should kind of make sense because think about it. Why don't I go through the ground right now? What's pushing me up? The electrons in the ground, right? Now, the electrons that is pushing me up are just right here. This small amount of electrons, and smaller for me than you, is right in that particular spot, right? And it's pushing me up. What's pulling me down? Of what? All of the Earth's mass. Every last bit of it is pulling me down. Those electrons are pushing me up. And they're tying. Electromagnetism is about times 10 to the 43rd stronger than gravity. That's how much more massive it really is. All right, third one, strong forces. We're not terribly creative in the scientific community. You can guess where these are on the ranking scale. Great job, yes. They're number 1. Strong forces take place, of course, in the nucleus, as do weak forces, and we'll talk just briefly about those in just a second. Fourth is weak forces, and actually it would make sense that those would be last, but they're not, because gravity's last, and these are third. I didn't see. Weak forces have to do with radiation, and that's all the more I'm going to say about them. About strong forces, real quick, have you ever looked at the atom over here and said, that doesn't make sense? Why? Why would you look at that and say that atom doesn't make sense?
Because the electrons are attracted to the protons.
That's one reason. What's the other? Yes?
The protons are all clumped together.
Yeah, and according to, if electromagnetism was the only thing happening here, what should all nuclei always do?
They should just go
They should explode, yeah. Nuclei should always explode if that was the only thing affecting them. And the reason they don't explode is because of strong forces. And that's actually the other reason why the neutrons are there. The neutrons are there actually because of strong forces to hold everything together. Holds nucleus together. As a matter of fact, they're so strong, it requires so much energy to take protons and neutrons out of the nucleus. Anybody know what type of reactions it takes to remove protons and neutrons? Nuclear reactions, right. A nucleus or a nuclear reaction, right. So when strong forces are in effect in a situation, you don't want to be around. If any of you learn or get a tip from any atoms in here that there's going to be protons or neutrons having a fallout and split apart, not fallout, you let me know. I won't show up that day. I will drive away very quickly. All right. So strong forces are, of course, the reason for nuclear reactions. These two, as you can kind of get a sense, aren't what we deal with on a day-to-day basis, right? Most atoms or materials that we deal with are stable, and they don't usually rip their nuclei apart and explode. Okay.